7-3 is in 2 days, but we're just going to do it in 1 day. Today. And so we're going to go through 7-3 day 1 and day 2 today. Day 2's a pretty short set of notes, so we're just going to do that today right along with 7-3 day 1. All right, so this kind of goes back to what we talked about last week. Last week, towards the end of the week, we talked about parallelograms, right? And we said, okay, if we have a parallelogram, these are some things that we know about it. And we talked about basically 4 theorems in a parallelogram. We said that opposite sides, the one thing we don't have a theorem for is that opposite sides are parallel, because that is the definition of a parallelogram. Top and bottom are parallel, left and right are parallel, so opposite sides are parallel. We don't have a theorem for that because that's part of the definition. But the first theorem that we talked about was opposite sides are congruent. Well, today we're going to do what we call the converse, right? And we've talked about converse throughout the year. We're flipping the statement around. So today we are proving that we have a parallelogram. So if I see a picture like this, and I see opposite sides congruent, then we know that we have a parallelogram. Okay? So if I have a 4-sided figure and both pairs of opposite sides are congruent, then we have a parallelogram. So that would help me to prove a parallelogram. So the big difference here is they're not going to come right out and say this is a parallelogram. We don't know if it's a parallelogram. We're trying to prove that, yep, it is a parallelogram. Okay? So that's one of the theorems that we did last week. Another one was opposite angles are congruent. So if B and D are congruent and C and A are congruent, then we have a parallelogram. And notice, we don't know if the sides are parallel. Okay? We're trying to prove that they're parallel by other information that we know. So that was the second theorem that we talked about last week. So using those 2 pieces of information, okay, going to the next page here, we have this ride at an amusement park, and the platform is swinging back and forth, and basically as I look at this, we want to know, in the diagram, AD and BC represent 2 of the swinging arms. So AD and BC are going to swing back and forth, okay? You got this ride that swings back and forth. And as it swings back and forth, is the size of this ride going to change? Well, it's not, right? The location that it's at, the arms are going to change angles, right? But this and this are still going to stay the same length, and the top and bottom are going to stay the same length. Okay, so what we're saying here is that the 4 sides are going to stay the same length, right? And so we want to know, explain why the moving platform represented is always going to be parallel to the ground. So this ride goes back and forth, right? And So we're going to say that the location will change. But the lengths stay the same. So if I tell you right now that the bottom of this ride is parallel to the bottom, it's always going to stay parallel, right? The ride's not going to offset. That would kind of give you like a tipping feeling. And in this case, it's going to stay planted right here, and the top and bottom would always stay the same. It's going to sway back and forth, but it will make a parallelogram. And the biggest thing that we know is that because opposite sides are congruent, that makes this figure a parallelogram. On this one here, I really like drawing a picture. Some of you could probably do this without drawing a picture, but kind of like we talked about last week, drawing a picture can be a really big deal here and give you a little bit of a visual of what's going on. So angle W is, let me rename those. So because W is an acute angle. So this would be 42. X is 138. Y is 42. It says to find the measure of angle Z. Now here's where you got to be really careful. Okay? Do we know right now that this is a parallelogram? No. Okay? We don't know if these sides or these sides are parallel. In fact, the question is asking us, is this a parallelogram? Okay? And so what's really important here is these are not automatically congruent. Okay? A lot of people would say, oh, this is 138, so this has got to be 138. That's only true if it's a parallelogram. Okay? But what do we know about all four-sided figures? 360. Okay? So we know that four sides are going to add up to equal 360. Thank you. And so we got to see what we got left over here. Okay? Doesn't matter what type of four-sided it is, we know it's going to add up to be 360. So I'm going to take 360 minus 42 minus 42 minus 138. Or you could add all those together and then subtract it from 360. You got some different options there. So what do I have left? Is angle Z 138? Anybody do the math? It works, yeah. Angle Z is 138 degrees, okay? And I'm going to tell you this because big ideas today, we have to kind of prove what we're doing here. So now we're going to say, why do we know that this is a parallelogram? So we're going to say, yes, it is a parallelogram. And we're going to say because both pairs of opposite angles are congruent. We don't know anything about the sides, but we don't necessarily need to know anything about the sides. But in this particular example, both pairs of opposite angles are congruent. Okay, this one, the question is going to be asked a little bit differently than last week. Last week, they told us it was a parallelogram, so we already knew these were congruent. Today, it's essentially the same question, but asked in a little bit different fashion. What do the lengths of these sides have to be in order for this to be a parallelogram? Okay, so for instance, what would be true about the top and bottom? If this is a parallelogram, what would we say about the top and bottom? They're congruent, okay? So that means that PQ has to be equal to SR. PQ is x plus 9. SR is 2x minus 1. And I started with the top and bottom here because look at the left and the right. On the left we have y, on the right we have x plus 7. Right now it doesn't do me a whole lot of good to set those two equal because I have an x and a y, right? I can't solve that when I have two different variables. But on the top and bottom, the only variable we have is x. So this is doable. I can solve this equation for x based on what we have. So as we solve for x here, we're going to subtract x, we're going to add 1, and we get 10 is x. Okay. And then using that piece of information, we also know that the other two sides have to be congruent. So we know that y has to equal x plus 7. And so we're going to plug this number right here in for x. And y would have to be 17. Now, what you could do is you could check this, right? If I took 10 and plug it in for x, 10 plus 9 is 19. 2 times 10 is 20 minus 1 is also 19. So that's just kind of proving that those two sides are congruent. Over here, this side is 17. And this side is 10 plus 7, which is also 17. So you could kind of do some work to verify that opposite sides are congruent by plugging it back in. They're not asking me to find those side lengths, but sometimes they might, right? Sometimes they may say, what is the length of PS or QR? And then you'd have to find that length. But here we're just finding the value of x and y. Okay, this one is different because it's angles. But the math is really not much different. What do we know about opposite angles in a parallelogram? They're congruent, okay? If this truly is a parallelogram, A and C have to be congruent, B and D have to be congruent. So we're saying that angle A must be equal to angle C, and we're saying that angle B has to be equal to angle D. For this to be a parallelogram, those two things must be true. So we have to find the value of y that makes that work. So for A and C, we're going to do 3x minus 32 equals 2x. And just to keep things positive, I'm going to subtract 2x, and then I'm going to add 32 over here. And that gives me x equals 32. Okay, B and D. B is 4y. D is y plus 87. So we're going to subtract y. And then 87 divided by 3. What's that give us? 29. Okay, so if x equals 32 and y equals 29, we have a parallelogram. If x and y equal any other values, this would not be a parallelogram. Those are the values that they must be to make this work. And that's what we're trying to find today. Very similar question to what we saw last week, so that's why it looks a lot the same, but the question is just asked slightly different. Okay, we did 4 theorems. We just talked about 2 of them, okay? And these are all converse theorems today. This one, though, is not something that we talked about last week. We said that if a figure is a parallelogram, both pairs of opposite sides are parallel, both pairs of opposite sides are congruent. Here, we're saying that one side, one pair of sides, one pair of opposite sides are parallel and congruent. And that's what's marked on this picture. Okay? And be careful here, because on this one, we don't know anything about AB or CD. We don't know if A, B, and C, D are parallel. We don't know if A, B, and C, D are congruent. All we know is that B, C, and AD are parallel and congruent. And that is a theorem that we can use. As long as we have one pair of sides that's both parallel and congruent, that means this is a parallelogram. Okay? So we don't have to do anything with the other pair of sides. That is not something that we talked about last week. This fourth theorem today is something that we talked about last week. Last week we said if it's a parallelogram, then the diagonals bisected each other. Here we're going to flip it. We're going to say if the diagonals bisect each other, then it's a parallelogram. Okay? And bisect means to cut in half. So what that means, BD splits AC in half, AC splits BD in half. Not all four of these have to be congruent. These two have to be the same, these two have to be the same. Not all four have to be congruent. So each diagonal has to be cut in half. If that's the case, then it's a parallelogram. So one of the things that you're going to have to decide is how and which one of these four theorems today am I going to use? And that's kind of where big ideas is going to come into play as well, where you have to figure out which theorem are we using to prove what we're doing. What kind of information do I have? So on this one down here, we have this doorway, part of a building in England. Over time, the building has leaned sideways. Explain how you know that SB and TU are equal. Okay? In this case, we want to know why would these two sides be congruent. Okay? So what we're going to say is STUV is a parallelogram because ST is congruent to VU and ST is parallel to VU. And that's marked, right? That is given to us. The arrow means parallel, the marking means congruent. So the bottom and the top sides are parallel and congruent. The fact that this is a parallelogram then, what do we know about the other pair of sides? They're congruent. So SV is congruent to TU. We could also say SV is parallel to TU, but it's not asking me that. It just wants to know how are they equal? Why are they equal? How do we know they're equal? Because we know it's a parallelogram, we know opposite sides are congruent. Okay, a quadrilateral has four congruent sides. Does the figure have to be a parallelogram? And there's a lot of different ways that we could draw that. In this case, drawing a picture could be helpful, right? We could draw one that looks like that. We could draw one that looks like this. But the one thing that needs to remain consistent is all four sides must be congruent. Okay, it doesn't necessarily mean it's a square, but does it mean that it's a parallelogram? Well, what are some different ways that we can prove it? One of the ways is both pairs of sides must be what? Equal, yeah. Okay, either they can both be equal or congruent, or they can both be parallel. We don't know anything about parallel here. Okay, it doesn't tell me that they're parallel. It does tell me that four sides are congruent. So if I have a quadrilateral and all four sides are congruent, what could I say about the top and the bottom side? Are they congruent? Yeah. Okay, what about the left and the right side? Are they congruent? All four are actually congruent, but all we really are worried about is opposite sides here. Okay, we're not worried about all four sides. Essentially, we just need to know that opposite sides are parallel, and we know that because opposite sides are congruent. Okay, so we are going to say yes, but then we got to decide which one of these is better. Is it yes because opposite sides are congruent, or is it yes because four sides are congruent? Which one of those would be better? Is four sides being congruent what we want to use? Is that one of our theorems? If we have four sides, then it's always a parallelogram? No. Okay, we want opposites. We have to use one of those theorems that we just got done talking about. So what we just said was opposite sides are congruent. The fact that we know the opposite sides are congruent, then we're going to use the parallelogram opposite sides theorem. This one's not really using a theorem. We don't have anything that says anything about four sides being congruent. Hey, when you name these theorems, and Big Ideas is probably going to use the name, but I have always told you that I'm probably good with you just using what the name says, which kind of go hand in hand in this case. But just look at the information that we have and determine why and how we can prove that these are parallelograms. Okay, and we have the four of them down here. These are the four names of the parallelogram converse that we're going to use today. So on Big Ideas, this is going to be helpful all in one place. These are your four theorems that you have to choose from. Okay, so on the first one, what do we know about the first picture on the left? Okay, these two sides are parallel. What else is true about the top and bottom? They're congruent, right? So the top and bottom, do we know anything about the left and the right side? No, we can't prove anything about the left and the right side. So in this case, we have one pair of sides that is congruent and parallel. Okay? Are we using anything about diagonals here? No. Are we using opposite angles? No. Okay? Are we using parallelogram opposite sides? This one means both pairs of opposite sides are congruent, and we don't know the left and the right. So this one is opposite sides are parallel and congruent. This one is the one that we want here. I'm not going to write the name out. I'm just going to say this one is D, because we have one pair of sides that is parallel and congruent. Okay, on this one here, what do we know about both pairs of opposite sides? They are what? What order would we use here? They're congruent. So this would be C. This is the parallelogram opposite sides converse. Both pairs of opposite sides are congruent. Pay attention to what's being given. Here, what are we given? We don't know any information about sides, right? What do we know? The angles, right? And what do we know about angles? What's true about these opposite angles? These two angles are congruent. These two angles are congruent, right? So we have two pairs of opposite angles congruent. So this would be B. Both pairs of opposite angles are congruent. Okay, we don't have one here that has diagonals, but that one would be really easy to see. If you had a picture of that one, it would look something like this. These two would be congruent. These two would be congruent. Okay, and that one's quite a bit different than the other because there's no angles and there's no sides marked, right? That one is different than the rest because it's talking about the diagonals inside. Okay, we saw some questions like this last week, but once again, the question is just asking us in a little bit different form. If these two are congruent, and in order to make this a parallelogram, what would be true about Fn and Dn? They have to be congruent, right? They have to be bisected. So we need the Fn to be equal to Dn. We need this piece to be equal to this piece. And so once again, it's just a matter of setting up the equation here. 5x minus 8 equals 3x. I'm going to subtract 3x. I do it this way just to kind of get rid of the negatives. I get 2x equals 8, and I get x equals 4. If x equals 4, those two would be bisected. Okay, same thing here. These two must be congruent. So we're going to say 2x equals 10 minus 3x. We're going to add 3x to both sides. And we're going to divide by 5. X equals 2. Okay, once again, I know we've only talked about 4 theorems today. That's because this one here is not a theorem. This is the definition of a parallelogram. Both pairs of sides are parallel. Okay? So if they're asking me to prove that a figure is a parallelogram, these are the 5 ways that I can do it. Right here, they're all stated on the same page. So this would be a good place for you to go back to as you go through your assignment today, because it tells you the name and it tells you what that means. Okay? So we put this here to help you out on your big ideas especially. Now, where would this come into play? So this last page here, if you look at this page here, if you were using the actual name, it would be this guy right here. The opposite sides parallel and congruent here. Okay, and it's going to be one of those like drag and drop things that we've seen the last couple of lessons. We have a figure, and the question says, is ABCD a parallelogram? Or show that ABCD is a parallelogram. And here's what I'm going to tell you. There's going to be some ways that are easier than others to do this. Okay? So try to pick out the one that's the easiest to do this, right? Try to make your life as easy as possible. So if I'm going to prove that sides are parallel, what do I use? What do I find? How do I show that sides are parallel? What do we use when we talk about parallel? How do I know that 2 lines are parallel, for instance? What would have to be true about the 2 lines? Same slope. Okay, the slope must be the same. Okay, so we're going to use slope to prove parallel. If we wanted to talk about the length being the same, what would we have to use? Distance. Okay. So if we're talking about length, we're going to use the distance formula. If I had to choose between the slope formula and the distance formula, which one of those is easier to determine? Slope, right? Especially if I have a graph given to me, because in order to find slope, I can actually just count, rise over run, right? If I was going to do the distance formula, I can't count because it's at a diagonal. All 4 of these segments are at a diagonal. I'd have to do the distance formula 4 times. You guys probably remember what the distance formula looks like. That's going to be a little bit of work involved, okay? Slope is not going to be that much work here. I want to go from A to D. So if I'm going to go from A to D, I'm going to go down 3. I'm going to go right 3. So we're going to do this. We're going to choose to do the slope here. So the first one is AD. We're going to go down 3. We're going to go right 3, which is -1. And I'm just going to work my way around. Actually, let's do BC, because BC is opposite of AD. So if I'm going to find BC, I'm going to go down 3. I'm going to go right 3. So it ends up being the same thing. -3 over 3, which is -1. So the first thing we're going to say is that AD is parallel to BC. But that's not enough, okay? 1 pair of sides parallel is not enough. We also have to prove that AB and CD are parallel. So now we're going to do AB. to go from A to B, we're going to go up 2, and then we're going to go over 1, 2, 3, 4, 5. Up 2 over 5. To go from D to C, we're going to go up 2 over 5. So now we've proven that AB is parallel to DC. So here what we would say is both pairs of opposite sides are parallel. Okay. Now I am going to show you an example of one that uses the distance formula here. You're going to have one like this on Big Ideas, which is why we put this here, to kind of show you the process here. Distance formula, we've used that enough. Hopefully you're starting to remember the distance formula. I'm going to put it on the notes here so that you have it, but hopefully you kind of remember it. Okay? It's a little bit more work than the slope formula, especially if we have a graph. But this one, it's trying to get us to show us that they're congruent. Okay? So in this case, they're saying JK equals LM, which equals what? So what they're really asking there is, what is the length? Remember, when there's no symbol above JK or LM, what are they asking? What does that mean when I have JK with no symbol above it? It's distance, okay? And so it doesn't come out and say, what is the distance? But we need to know that's what it means. JK and LM with no symbol above it mean distance. So we need to find the distance of JK, and we need to find the distance of LM. Well, that's a little bit tricky here because I can't just count. Okay, so that's where your distance formula is going to come in. So let's find the distance of JK, first of all. We need to know what the ordered pairs are for J and K. So J is -3, -5. K is at -4, 1. So we're going to plug that into the distance formula. -4 minus -3 is -4 plus 3. 1 minus -5 is 1 plus 5. So this would be 1 plus 36, which is radical 37. And we're going to leave it like that because that's not a nice, perfect whole number, right? It would give me a decimal. So to skip rounding. Now, what I would need to do then is I would also need to prove that LM is also the same thing. So I'd have to find the length of LM and find the same thing. But these two are going to be congruent. So just to save a little bit of time. They're asking me what the length of these two are. They're both radical 37. Therefore, we know that JK is congruent to LM. Once again, this is what it's going to look like on Big Ideas. So this is how you're going to fill in these problems like this. The slopes of JK and LM. So if I'm going to go from K to J, I'm going to go down 1, 2, 3, 4, 5, 6 over 1. Much, much easier than doing distance formula, right? All I got to do is count. I'm going to go down 6. I'm going to go right 1. So that's -6 over 1, which is -6. I could do the same thing for LM. 1, 2, 3, 4, 5, 6, right 1. They both have the same slope. So they're both congruent. They're both parallel. They have the same slope. So we're going to say that JK and LM are parallel and congruent. one pair of opposite sides are congruent and parallel. Or the name of the theorem would be the opposite sides parallel and congruent theorem. You could do it either way. Big Ideas, I think, uses the actual name. So, okay, that's what we got.